Good day, ladies and gentlemen. Today, we're going to go a bit deeper into the Candice AI for Games plugin and learn how to customize it using the Candice behavior trees. But first, let's roll back a bit and grasp the fundamentals. Firstly, we have the Candice AI controller that essentially controls everything from our movement, combat, that includes attacking and receiving damage, and of course detection. That also includes obstacle avoidance. The Candice AI controller communicates with the Candice AI manager, primarily for pathfinding. So every agent will make a request to the Candice AI manager and receive the calculated path in due time. The second reason for the AI manager is also for registering all agents within the scene. So if for whatever reason you wanted a list of all the registered agents, you will do so with the Candice AI manager. There can also only be one instance of the Candice AI manager per scene, and of course as many Candice AI controller instances as your machine can handle. Now on to the Candice behavior trees. The Candice behavior trees operate identically to regular behavior trees, and like regular behavior trees, we have composite nodes such as selectors and sequencers, decorator nodes such as the inverter, and finally our leaf nodes, also known as action or task nodes. There are two distinct types of leaf nodes. The first being conditions, which basically do checks such as is the enemy detected, is the player health low, is the game over, etc. And our second type of leaf nodes are the actions, which by the name suggests they actually do stuff. For example, open door or attack or flee. Before we can customize Candice, let me actually show you how to build behavior trees through code. So right here I have a very basic project folder that only has my Candice AI for Games plugin in. So let's navigate within the folder and then inside the scripts folder and into libs and finally into the Candice behavior tree folder. In here we'll find all the building blocks for the Candice behavior tree system, but what we're looking for is the Candice behavior tree mono. This file is a perfect example of building a behavior tree programmatically. Firstly, we have our root node. Right now this is a sequence, but it could be a selector, it could even be an action node. From there we have all the other different kinds of nodes that we're going to use to build our behavior tree. So what you see here are building blocks that we'll use to build our complete behavior tree. So as we navigate more down, from the beginning in our start function we declare our root node. It's a sequence and then we initialize it with the transform and the AI controller. So as you can see from the beginning, our behavior tree will always have a reference to the Candice AI controller as well as the transform that the agent is attached to. So all of our actions that we will eventually see later on will be able to utilize these fields, and that's very powerful. From there, our update function simply calls the evaluate. This evaluate function is what we use to actually run the behavior tree every frame. So without this, in our update function, our behavior tree would not do anything. So it has to be there. So now from here, we actually have the specific functions that we use to build our behavior tree, or I would say append them to our root node, which we declared at the start. And as you can see, we have 3 other functions: aggressive AI ranged, wonder AI, coward AI, and the one we're using right now is the aggressive AI melee. The only difference between these 4 functions is the nodes they use, and I would say a bit of the order as well. But as you can see, for example, the aggressive AI ranged, at the root level we have a scan for objects node, can't see enemy node, and attack or chase selector, which is pretty much identical to the aggressive AI melee. And the only difference here is in our attack or chase selector we have an attack sequence, and in our attack sequence we have an attack node which calls the attack melee function. And in our aggressive AI ranged, it's pretty much the same. We also have the attack or chase selector, which also has an attack sequence, and finally the attack sequence instead has a ranged attack node which calls the attack ranged function. From our root node level, we simply just have a scan for objects node that scans for objects, a can see enemy node which is a check that checks whether the agent can see an enemy, and if the agent can see an enemy, we run the attack or chase selector that again has an attack sequence. We first check is the enemy within attack range. If so, we can continue to look and attack at the enemy. If not, we want to follow the enemy, and that's it. It's pretty much the same for the aggressive AI ranged, coward AI. The only difference with the coward AI is we don't have any attack sequences and whatnot. We just have normal scan for objects. If an enemy is detected, we want to flee, and yeah, this is how that works. And the wonder AI also similar, even shorter. So you can play around with these and the nodes and see the kind of behavior you get. For example, you could call the Candice pathfind node first and the avoid obstacles node after, and then what would happen is the agent would pathfind first, and then as it's following the path, avoid obstacles along the way. Pretty powerful, a bit CPU intensive I would say, but pretty powerful in order to build AI that can move pretty, I would say, realistically or lifelike. So now, customizing our Candice AI for games or the behavior tree system is as simple as adding new custom code for the leaf nodes to use. In order to do this, we need to navigate to the Candice default behaviors folder, or rather script. In here, as you can see, we have all the functions that we were using in our Candice behavior tree model. So as you can see, we're calling, for example, for our scan for objects node, we call scan for objects within the Candice default behaviors class, and there it is, scan for objects, and all the other functions are here. You don't have to use this class. You could easily create your own class with static functions and just use them here also, so you're not limited to that. But in this case, for this is where the logic lies, or the bridge to the logic. For the case of, for example, our scan for agents node, we get a reference to our AI controller from the root node, and then we just call the scan for objects node within our AI controller. We could have easily put all that logic in here, but then it would be a bit messy. This class would be very, very huge. But again, we could have easily put all that logic that lies within this function here. A good example of that is down below here. We have a rotate to function. This logic should actually be also in the AI controller. I think I was probably just too lazy to move it. but it will probably be moved eventually. But again, this is a very good example of having the logic right here in the thing. But you could imagine if all of these functions had the logic here, how many lines would this class be? 2005 more as we add more functions. So yeah, this is just a bridge, and basically all the logic lies in our AI controller. So now let's create another action. Let's say let's create a movement function. What movement functions do we have here? Let me scroll up. We have move forward, and we have move forward with slope alignment. The only thing these do is it calls move forward, calls, we get a reference to our AI controller, and then we call move forward within our movement module. The movement module is nothing more than just a class that has movement functions, as simple as that. Let me show you briefly. We have our AI controller, and here's our movement module. That's it. And if I navigate to this movement module, as you can see, it's just functions. I could have again easily just thrown these functions in the AI controller and just called them directly, but then the AI controller would be a mess. And again, I could have also just instead thrown all those functions in here and just manipulate the agent and the transform straight from here, but again, that would make this file super messy. So long story short, it's that simple, but nothing is stopping you from doing that if you wanted to implement, if you wanted to put your own logic here. So right, we have a move forward function and a move forward with slope alignment function. This simply does exactly what move forward does, but with slope alignment. They're separated because this is a bit more CPU intensive than just move forward. So let's make a function move to point. It's going to be easy. The only thing we have to do is literally create the function. I already have a snippet of code, so I'm going to paste it and explain the lines. So right here, our function has to be public, static, and return Candice behavior states. The name can be whatever you want, and the parameter has to accept Candice behavior node. You can name this whatever you want, but it's called root node because it is the root node that we're receiving through this parameter. So we declare Candice behavior state, and we default it to failure. We get a reference to our AI controller, and then we call the move to point function that's within our movement module. Unfortunately, this function does not exist yet, so we're gonna have to create it. And then after that, we set our state to success, and we're done. So let's navigate to our Candice AI controller and find our movement module. Here it is. Let's navigate to this, and in here we have our movement functions. I have another snippet of code, so I'll just paste it and again explain the lines. So here's our move to point function. We accept the transform and the AI controller. So we call transform.lookAt, and we get the move point from our AI controller. This line simply just looks at the move point, and then we just move forward. And that's it. It's that simple. From there, we can actually use it. First thing we're going to do is declare a move to node. Then we can instantiate this move to node. I'm going to duplicate the move node as well. Move to node, and the function I want to call is the move to point that we created. And that's it. Now from here, the only thing we need to do is actually just use it. So we could say move node, and instead of saying move node, we can call move to node. Now in this case, we're going to clash a bit with our obstacle avoidance and because our obstacle avoidance rotates our character when an object or an obstacle is detected nearby, and our move to node rotates our character to the target. So it's kind of overwriting what our obstacle avoidance node does. So it could have been, I guess, improved a bit, or probably just not used with the obstacle avoidance. The pathfinding, definitely, but not the obstacle avoidance. But that was just an example on how to create new actions and easily use them in our behavior tree. From here, it's all about how complex, or I would just say advanced, the functions you implement are in order to create the most advanced AI. And from there, I would say that would pretty much sum it up. So thank you for watching, and if you enjoyed this video, don't forget to like, subscribe, and leave a review on the Unity Asset Store. So this is goodbye for now, and I'll see you in the next video. Bye.